Section 300.22c2 of the National Fire Protection Association 70, which is the National Electrical Code, addresses wiring in ducts, plenums, and other environmental airspaces. Specifically, Part 2 refers to other spaces used for environmental air. This section dictates that wiring methods permitted in these spaces must be suitably supported. The intent is to prevent damage to the conductors or their insulation, ensuring the wiring remains intact and safe. Poorly supported wiring can sag, rub against surfaces, or be subjected to undue stress, which can lead to insulation damage and potential electrical hazards such as short circuits or fires. Section 307.2 of the International Building Code concerns the enclosure requirements for dumbwaiter shafts. This section specifies that dumbwaiter shafts must be enclosed with walls or partitions that have appropriate fire resistance ratings. The enclosure aims to prevent access to the shaft from areas outside of it, minimizing the risk of accidental falls or unauthorized entry. The walls or partitions must extend from the base of the shaft to the top, creating a continuous barrier. Any openings in the enclosure, such as access doors, must also be fire-rated and self-closing to maintain the integrity of the fire separation. The purpose of these enclosure requirements is to provide a safe and protected environment within the building, reducing the potential for accidents or injuries related to the dumbwaiter shaft. Section 300.20 of the National Electrical Code focuses on preventing inductive heating in metallic enclosures or metallic raceways. When conductors carrying alternating current pass through metallic enclosures, such as metal boxes, cabinets, or raceways, they can induce circulating currents in the metal if the enclosure is not properly designed. These circulating currents can cause the metal to heat up, potentially leading to insulation damage, fire hazards, or energy loss. To mitigate this, the code requires that conductors be arranged in a way that minimizes the magnetic field surrounding them. This is typically achieved by grouping all circuit conductors, including the grounded conductor or neutral, within the same enclosure or raceway. By doing so, the magnetic fields produced by the conductors tend to cancel each other out, reducing the induction of circulating currents in the metal. Loose or poorly supported wires present a significant fire hazard, primarily due to the risk of arcing or short circuits. When wires are not properly secured, they can move and rub against each other or nearby surfaces. This friction can gradually wear away the insulation, exposing the bare conductors. If these exposed conductors come into contact with each other, it can create a short circuit where electricity bypasses the intended load and flows directly from the source to the return. This sudden surge of current generates intense heat, which can ignite nearby flammable materials such as dust, wood, or insulation. Arcing, another potential consequence of loose wiring, occurs when electricity jumps across a gap between two conductors. This creates a visible spark and extremely high temperatures capable of igniting nearby combustibles. The risk of fire is amplified in environments with a high concentration of flammable materials or where the wiring is located in concealed spaces, making early detection and suppression more challenging. Regular inspection and maintenance of wiring systems are essential to identify and address any signs of looseness or damage, reducing the likelihood of fire. An open dumbwaiter door presents a serious fall hazard for anyone who may inadvertently access the shaft. Dumbwaiter shafts are typically narrow and deep, creating a significant vertical drop that can result in severe injury or even death if someone were to fall into it. The risk is particularly high if the dumbwaiter is located in an area with foot traffic or where individuals may be working or moving around. An open door eliminates the physical barrier that normally prevents access to the shaft, making it easy for someone to accidentally step or stumble into it. This risk is further exacerbated if the area around the dumbwaiter is poorly lit or cluttered, reducing visibility and increasing the likelihood of a misstep. Safety measures, such as keeping the dumbwaiter door securely closed and locked when not in use, are crucial to prevent accidental falls. Additionally, warning signs and barriers can be installed to alert individuals to the presence of the hazard. The presence of wires within a dumbwaiter shaft introduces a potential electrical shock hazard, particularly if individuals attempt to grab onto or climb on the wires. Wires that are not properly insulated or that have damaged insulation can expose live conductors, creating a direct path for electricity to flow through a person's body. If someone touches a live wire while in contact with a grounded surface, such as the metal frame of the dumbwaiter or a nearby pipe, they can receive a severe electrical shock. The severity of the shock depends on factors such as the voltage, current, and duration of exposure, but even a brief shock can cause muscle contractions, burns, or cardiac arrest. The risk is heightened in damp or wet conditions, as water significantly increases the conductivity of electricity. Additionally, the wires within a dumbwaiter shaft may be subject to damage or wear over time, further compromising their insulation and increasing the likelihood of electrical shock. It is essential to keep all wiring properly insulated and protected and to avoid any contact with wires in potentially hazardous environments such as a dumbwaiter shaft. There are several key recommendations that can be implemented to address these electrical and safety concerns. Firstly, it is recommended to reroute the wires through proper conduit or cable trays. This provides a secure and organized pathway for the wiring, protecting it from physical damage and reducing the risk of insulation wear. Conduit and cable trays also offer a means of supporting the wires, preventing them from sagging or coming into contact with other surfaces. When selecting conduit or cable trays, it is important to choose materials that are appropriate for the environment and that comply with relevant electrical codes. For example, in damp or corrosive environments, non-metallic conduit may be preferred to prevent rust or corrosion. It is also crucial to ensure that the conduit or cable trays are properly grounded to provide a safe path for fault currents in the event of an electrical fault. The support system should be designed to handle the weight of the wiring and to withstand any potential vibrations or stresses. Secondly, securely closing and locking the dumbwaiter door on the second floor is essential to prevent accidental falls into the shaft. This measure creates a physical barrier that restricts access to the potentially hazardous area. The lock should be robust and tamper-resistant to prevent unauthorized entry. Regular inspections of the door and locking mechanism should be conducted to ensure that they are in good working order. Any damage or wear should be promptly repaired or replaced. In addition to locking the door, warning signs can be posted to alert individuals to the presence of the dumbwaiter shaft and the potential fall hazard. These signs should be clearly visible and easily understood even by individuals who may not be familiar with the area. Thirdly, installing a full arrest system or other safety measures can provide an additional layer of protection to prevent falls into the shaft. A full arrest system typically consists of an anchor point, a harness, and a connecting device such as a lanyard or self-retracting lifeline. The harness is worn by the individual working in the area, and the connecting device attaches the harness to the anchor point. If the individual were to fall, the fall arrest system would arrest the fall and prevent them from hitting the bottom of the shaft. Alternatively, other safety measures, such as guardrails or safety nets, can be installed around the perimeter of the dumbwaiter shaft to prevent falls. The choice of safety measure will depend on the specific circumstances of the installation, including the height of the shaft, the frequency of access, and the types of tasks being performed in the area. It is important to ensure that any fall arrest system or safety measure is properly installed, inspected, and maintained in accordance with relevant safety standards and regulations. Finally, consider hiring a licensed electrician to inspect the wiring and make necessary repairs or upgrades. A licensed electrician has the knowledge, skills, and experience to identify and address any electrical hazards or code violations. They can assess the condition of the wiring, identify any areas of damage or deterioration, and recommend appropriate repairs or upgrades. Electricians can also ensure that the wiring complies with all applicable electrical codes and regulations. When hiring an electrician, it is important to verify that they are properly licensed and insured. This provides assurance that they have met the necessary qualifications and that they are protected against liability in the event of an accident. Obtain multiple quotes from different electricians and compare their prices and services. Ask for references and check their reputation before making a decision. The installation of new wiring in an existing dumbwaiter shaft may require a permit from the local building department. This is because electrical work is typically regulated by local building codes to ensure safety and compliance. A permit is a formal authorization from the building department to proceed with the work. Obtaining a permit typically involves submitting plans and specifications for the proposed electrical work, paying a fee, and undergoing inspections by building officials. The purpose of the permit process is to ensure that the electrical work is performed in accordance with applicable codes and standards. Building officials will review the plans to ensure that the wiring is properly sized, protected, and installed in a safe manner. They will also inspect the completed work to verify that it meets the requirements of the code. Failure to obtain a permit when required can result in fines, penalties, and delays. In some cases, the building department may even require that the unauthorized work be removed. It is always advisable to check with the local building department to determine whether a permit is required before commencing any electrical work. It is important to consult with local codes and regulations for specific requirements related to the use of dumbwaiter shafts for wiring. Electrical codes and building codes vary from jurisdiction to jurisdiction, so it is essential to understand the specific rules and regulations that apply to your location. Local codes may impose additional restrictions or requirements beyond those outlined in the National Electrical Code or the International Building Code. For example, some jurisdictions may prohibit the use of dumbwaiter shafts for wiring altogether, while others may allow it only under certain conditions. Local codes may also specify the types of wiring methods that are permitted in dumbwaiter shafts, as well as the requirements for support, protection, and access. In addition to electrical and building codes, there may be other local regulations that are relevant to the use of dumbwaiter shafts. For example, fire codes may impose restrictions on the types of materials that can be used in the shaft, while accessibility codes may require that the dumbwaiter be accessible to individuals with disabilities. To ensure compliance with all applicable codes and regulations, it is advisable to consult with a qualified professional such as a licensed electrician or a building inspector. They can provide guidance on the specific requirements that apply to your situation and help you to avoid costly mistakes or violations.